Good afternoon. As Kandaga mentioned, my name is Samantha Ouertani, and I work within the Global Drifter program. For today's seminar on the Global Drifters ERDDAP server, I'm very excited to discuss the many advantages that an ERDDAP server can bring, especially from the perspective of the Global Drifter program's Data Assembly Center. So here's just a quick outline of what I will be discussing today. Of course, I will explain what an ERDDAP server is. Then I'll touch on the Global Drifter program's data flow so that you can see how our data sets and derived products are produced. And I will give some brief instructions on how to set up an ERDDAP server. And of course, I will discuss the benefits for data distributors as well as data users. And I will briefly touch on the Global Drifter program's public ERDDAP versus the private ERDDAP and the benefits of both. And towards the end, I'll get into the user metrics and how you're able to track them from an ERDDAP server. And then finally, I will provide some tutorials and resources for those of you that are interested in setting up your own ERDDAP server. So of course, let me start off by explaining what an ERDDAP server is. ERDDAP was created by NOAA Fisheries to promote easier access to scientific data sets. And in its simplest form, an ERDDAP server that you can see in the diagram here in the center sits between this left-hand side, which are the data sources, so they can be served locally or remotely. And it reads in data from many different file formats, and then it pushes that data to data users through a number of ways. So I will be referencing this diagram a lot, but we're going to start out here in the left-hand corner. And taking a step back, I know that many of us in the room and many of us online currently push data updates through FTP servers. And that is something that the Global Drifter program used to do before the implementation of our own ERDDAP server. And so I know that with your FTP server method, you might be wondering why you would make the transition to an ERDDAP server if you already have a data distribution system that works perfectly fine. The issue that we found was that FTP servers don't allow us to easily track who uses our data. And we all know how important that is for providing information to our program managers and securing our frequent funding. So an ERDDAP server completely changes that game, and it allows us to powerfully track the user metrics. So let's start moving through this diagram by looking at the top left, looking at local data sources that feed into the Global Drifter program's ERDDAP. So here's an overview of the data flow that happens here at the Data Assembly Center to generate our local files. Drifter data starts all the way out here on the left with our drifter transmission. So every hour on the dot, we have a drifter that transmits recorded sea surface temperature and location to a satellite passing by overhead. And that satellite then sends one short burst data message or an SVD message to our sensor here at AOML, the SVD Decoding and Message Archive. At this point, the decoded messages are posted onto the GTS, the Global Telecommunications System, and this is made available to the public on the OSMC ERDDAP, the Observing System and Monitoring Center, by a colleague of ours at OSMC. This then forms our very first GDP data product, which is the raw/real-time GTS data. Now, we also work very closely with OSMC, and we have been able to provide this data product on our ERDDAP, even though it is the OSMC's product. Going back to AOML, then after we decode the messages, we're looking at roughly 31,200 messages a day, and that is sent to our raw data repository, where our team, the Global Drifter program, performs some heavy crunching, and we also perform some quality control procedures, which results in our first two data sets, the 6-hourly and the hourly quality control sea surface temperature and velocity data sets. From our QC data sets, then we're able to derive some products. So we have our climatology product, our loopers product, and our deployment value maps, just to mention a few. So from this flowchart, you can see that the GDP handles enormous amounts of data streams per day, and we are responsible for a large number of data products. So this is where the ERDDAP server comes in, and it allows us to serve all of these data products in one place in an easily accessible manner. So I did mention in the outline that we have a GDP public ERDDAP and a private ERDDAP. These are the products that are currently available on our public ERDDAP. So as you can see, we have our 2 QC datasets, hourly and 6-hourly SST and velocity. We also have made available the OSMC real-time data from the GTS on our ERDDAP. We have our 3 climatology products, our annual means in current velocity, our monthly means in current velocity, and the variance in current velocity. We also have our 2 looper products, the looping trajectories and the non-looping trajectories. These are the products that are currently available on the ERDDAP, but there are more to come, including the deployment value maps. Now here we have a screenshot of the Global Drifter Program's ERDDAP. So you can see how the data sets from the previous slide translate to the ERDDAP server. So this is the exact same thing as the previous slide, but now we are seeing how the data sets are presented on an ERDDAP server. So every row that you see here is one data set. So as you can see at the top, we have our 2 QC drifter data sets, our 3 climatology products, our 2 looping trajectory products, and we have the OSMC real-time data, which shows the last 90 days of data from the GTS. Very quickly, some brief instructions on how to set up your own ERDDAP server. The most beneficial thing about ERDDAP, in my opinion, is that it is completely free and open source software, so you do not need to pay for anything to create your own ERDDAP. You should know that the ERDDAP is built on a Java-based application called Tomcat, and then it is combined with the ERDDAP file package. So all you need is to download those 2 separate programs, and then you can start configuring the files to the liking for your own research group. So that includes just creating some basic directories and creating the URL that users will be able to click on and visit your ERDDAP from. Once you have been able to get the basic ERDDAP setup up, and you can see the sample data sets that ERDDAP provides, then you know that you are ready to start ingesting your own data sets from your research group. And to do this, you need to determine if your files are going to be hosted locally. So are the files going to be hosted on the same machine as your ERDDAP, or are they going to be hosted remotely? Is the ERDDAP going to reference another ERDDAP or another server that you use to hold data? Once you figure that out, then you can begin describing your data sets as a small chunk of XML code, and you add that to this file called the datasets.xml file, which is the skeleton of the ERDDAP that tells ERDDAP where to look for your files, how to describe your data set, and ultimately how to represent your data set on the ERDDAP. Lastly, if you are interested in pushing your ERDDAP to the public, you of course need to push it past the firewall. So to do so, you're going to need to work with your division's IT specialists and CNS here at AOML, just to ensure that your ERDDAP meets the security requirements. So this is a condensed version of the instructions, but for a list of step-by-step instructions, you can visit the ERDDAP GitHub page under the setup HTML file. I will include this link in the end of my presentation. Now, of course, there are some expected hurdles with setting up an ERDDAP server, but with the benefit of retrieving user metrics and seeing who is using their data, I think that these hurdles are well worth overcoming. So the first minor hurdle is that you need to represent your data sets as XML code. This is something that was new to me, but don't worry, because the ERDDAP comes with a pre-installed shell script that can create a draft of XML code after you are able to input some information about the data set. So it makes it pretty seamless. Another hurdle that we had to overcome was that we had to share a web server with someone else's ERDDAP within PHOD. So this just requires some extra coordination and extra time with your IT specialists from your division. But our division has been able to do it. We've been able to share a web server with another group, and our ERDDAPs are completely separate. But from a technical point, they share the web server. And so that's just something you will have to coordinate with your IT specialists. Jay is not here right now, but I just wanted to say thank you to Jay for restarting the server so many times, especially as we were figuring out how to share a web server and making some other changes. So with ERDDAP, you're going to need to make some base changes, some base setting changes when you're first setting it up. And the only way that ERDDAP will recognize these changes is if you restart the underlying Java application called Tomcat, or you can simply restart the server that the ERDDAP is hosted on. So additionally, I had to restart the server a couple of times as I adjusted the memory allocation. So there are two settings, the XMS setting and the XMX, which is the minimum and maximum memory pool allocations for Java. And so you just need to see how large your data sets are, how much do you want your users to be able to download at once, is the virtual machine that you're hosting the ERDDAP on, does that match up with the memory allocation? So those are just some more adjustments, and that is included in the base settings. So when you adjust that and when you play around with those settings, you do need to perform some server restarts. Additionally, as I mentioned earlier, pushing ERDDAP past the AML firewall will just require some more time and coordination, but that is in the hands of the IT specialists and CNS, so just account for the extra time. And finally, once your ERDDAP is available to the public and available to your data users, it's also available for web crawlers. And web crawlers can just add erroneous requests to the weblog files, and they can just kind of cloud it with like dummy requests. So you need to be able to determine if those requests are made from a real human or if it's just a web crawler. I'm currently dealing with that issue, but there are ways to go around it, especially if you're able to implement a robots.txt file to tell web crawlers how to correctly navigate your website. Okay, now we can get into the benefits for data distributors. As I've mentioned, it's completely free and open source software. There's also a great established supportive community. So the creator of ERDDAP, Bob Simons, he made a Google Forms that you can just type up your question, and either one of the administrators or someone else within the community can just jump in and answer your questions. So that has been very helpful to me as I was troubleshooting the ERDDAP. Additionally, ERDDAP has the versatility to serve both gridded and tabular data sets. So for example, the Global Drifter program, our QC 1 hour and 6 hourly data sets, those are trajectory data sets that show how a drifter moves through space over time. So that is an example of a tabular scientific data set. But then we also have the climatology products, which are resolved to 0.5 degrees. And that is something that would be interpreted as a gridded scientific data set. So ERDDAP offers both of those capabilities. As I alluded to early on, you can serve data files from local files that are on the same machine as your ERDDAP, or you can reference other ERDDAPs or other web servers that you might already have in place. Our team also has been able to fully automate some cumbersome aspects of database updates. So with the ERDDAP, we've been able to implement some cron jobs that just point to a directory where we dump our new updated files, and that cron job just sends them over to the virtual machine with our ERDDAP, and it just restarts the data set to load in those new files. Additionally, and very importantly, ERDDAP is able to pull metadata from source files very well. The one requirement is that you need to document your metadata clearly within your source files. So our team has mainly used NetCDF files to ingest data sets, and NetCDF is just a great option for documenting the metadata as source attributes. And then ERDDAP can pull those in, and they can list them as the dataset attribute on the metadata page, or they can list them as a dataset's variables that you can then query. Okay, so continuing with the benefits for data distributors, this is a flowchart of what our data distribution looked like before we implemented the ERDDAP server. So here at the top, of course, we start with the Drifter Data Assembly Center. And once we have one data set that is ready to push an update to the public, so for example, our hourly QC, SST, and velocity data set. In the past, what we had to do was we had to push it to our public FTP server, hosting data and metadata. And then we also would push it to some individually created links for individual FTP servers for those users that are in remote locations. Then we would manually send our files for the new update to our partner at OSMC for upload into the OSMC ERDDAP. We would also send the files to Coriolis for archival at their center. And then our partner at OSMC would also hash the new file updates to send them to NCEI for archival purposes. So as you can see, this data flow structure is quite fragmented, but the ERDDAP can streamline everything. So before I show you the flowchart of what our data distribution looks like with the implementation of an ERDDAP server, I just want to reference back to our diagram. So we've covered what our local source files are going into the GDP ERDDAP are, but we are also referencing some remote sources. And ERDDAP has quite a powerful capability to link ERDDAP servers together in what's called a federation of ERDDAP servers. So through a federation, other ERDDAPs are able to link datasets from other ERDDAP servers. So if you look more closely at this diagram, you can see that there's a bidirectional arrow flowing between the GDP ERDDAP and the OSMC ERDDAP. So this is indicating that our GDP ERDDAP is referencing a data set from the OSMC ERDDAP, and that the OSMC ERDDAP is referencing several data sets from the GDP ERDDAP. Now, this is really powerful because in the past, when we would send our files to OSMC for upload on the OSMC ERDDAP, users were able to access our data quite easily from an ERDDAP server, but there was no connection to our team. So when we were telling program managers that our data is available here on the OSMC ERDDAP, we couldn't tell them what the metrics are and what the metrics look like because this was not our machine and we had no access to it. But with an ERDDAP server, since the ERDDAPs are linked and essentially our data sets are being referenced by another ERDDAP, the clicks and the metrics will come back to us and we're able to see where our data is hosted and how it is used. Something very similar is true for the Coriolis ERDDAP, except that they are only referencing data sets from us. We are not referencing any data sets from them. But this structure that I'll show more deeply in the next slide is a federation of ERDDAP servers, and it's just great for promoting interagency collaboration. We've been able to promote other ERDDAP servers. We're able to regain control of our metrics, and we're able to harmonize the data flow and control the data version when we have new updates. And if I did not make it clear, we no longer manually transfer files to our partners at PMAL and Coriolis. The federation of ERDDAP servers has replaced that structure. So here is the flowchart showing the data distribution now that we do have an ERDDAP server. So once again, starting at the data assembly center, we have prepared an update for one of our QC datasets. Again, for example, our hourly SST and velocity. Now with our ERDDAP server, we simply send the files to our GDP ERDDAP. And because Coriolis and OSMC, their ERDDAPs are linked to ours in a federation, they simultaneously will receive the update. So any new update is just pushed in a harmonized manner. And additionally, we still upload files to our public FTP server, but we're going to phase this out. We still upload files just for our legacy users, but hopefully down the line, we plan to eliminate and discontinue this option. Lastly, we still are hashing files, updated files, to send to NCEI for archival purposes. We did try to include them in our federation of ERDDAP servers since they have their own ERDDAP, but their protocols for archiving files are quite strict. And since downloading a file from ERDDAP will overwrite the timestamp of the original file's timestamp creation, that just kind of breaks their protocols and doesn't allow them to know when to archive a file. So this is the new streamlined data flow, but please keep in mind that all of this is true for one singular data set. And as you know, the GDP is responsible for a number of data sets and products. So this flow is true across a number of products. Now we can get into the benefits for data users. So one of the most exciting things is that ERDDAP is able to provide over 50 different file format downloads to users. And here are some of the 50. I could not list all of them, but hopefully you can see some of your favorite file type options. And just know that this is going to increase scientific data access because your users will no longer have to convert between different file types just to work with your data. Something else that's really great about ERDDAP is that it's able to represent one singular data request as a static URL. And this is quite powerful because then you can implement something called machine-to-machine transfer. And you can create a script that writes your URL for your data request without ever needing to access the ERDDAP interface. And this is through a process called the RESTful API. And as another example, there's also a Python module called ERDDAP, and that is great because it already has the commands and functions built in to create your own ERDDAP URL from your request constraints. So you can essentially just pull data from the ERDDAP by scripting it into MATLAB or ArcGIS, Python. So it's quite powerful in that way, and you can automate some of your request pools. Lastly, the time format and the time variable across all ERDDAP data sets and across all ERDDAP servers is the same. You do not have to worry about converting between time units and time formats when you're looking at different data sets across different ERDDAP servers. So all of these benefits help to make ERDDAP adopt the fair data access principles, making data access more easily findable, accessible, interoperable, and reusable. Now we can get into the user metrics. As of right now, the Global Drifter program currently tracks the number of downloads, the number of total downloads since we have released our ERDDAP server. And within that, we're tracking the total number of unique users that have made download requests or that have downloaded data, sorry. We also track the total number of downloads broken down by file type and the total number of downloads broken down by month. Looking forward, we plan to also track the popular Drifter deployment areas of interest by looking at individual requests and where people are looking around the world for Drifter data. We also would like to track download trends over time. And we are looking to track the number of downloads broken down by dataset type. So 1 hour QC dataset, 6 hour QC dataset, looping trajectories, and so on. And then we would like to reproduce these individual metrics above per each dataset. So we actually have made a dashboard to host these metrics that we currently track, and it is now live, but there are, of course, further enhancements to come. So here are all of the figures that we currently have posted on our ERDDAP metrics dashboard. I will briefly run through them. In the top left, we have the number of visitors, the visitors scaled by the number of requests, plotted by location across the globe. In the lower left, we have been able to track the number of ERDDAP downloads by day for the month of January. Here in the bottom middle, we're tracking the number of total downloads broken down by file type. So you can see that our most popular file type is a .NET-CDF file. Here in the top right, we are tracking the number of total ERDDAP downloads by month for the year of 2023 since we released the ERDDAP server, which we released in May of 2023. And finally, this graph on the bottom right shows you the total number of downloads broken down by country since the release of the ERDDAP server. And currently, I'm not showing any metrics from South Korea or China because we are seeing a large number of web crawlers from those two countries. And until I can verify what is a genuine request, I'm excluding those countries for now. But of course, I hope to add them back in to our final metrics dashboard. And lastly, we're tracking the total number of downloads since the release of the ERDDAP and the total number of visitors that have made download requests since the release of the ERDDAP. All of these were last retrieved on February 5th of 2024. So here is a screenshot of the metrics dashboard. And these are all the same figures. There's additional figures at the top of the page. Sorry. But you can see that ERDDAP is just really powerful because now you can retrieve your metrics, you can host them on a dashboard, and you can make this dashboard available to the public. You can point your program managers to it when they're looking for the yearly updates and just direct them to the most recently updated metrics. So I mentioned earlier that we have a private GDP ERDDAP in addition to a public GDP ERDDAP. So they are almost identical in that the private GDP ERDDAP has the same data sets as our public ERDDAP, but it has two additional data sets. It has a global bathymetry and topography data set and the real-time short burst drifter data set. And so this private ERDDAP is only available if you have access to FODNet. But these are two data sets that, well, first of all, the global bathymetry from Tozer et al. 2019 is not ours, but it's helpful in making graphs, and it's easy just to pull data from an ERDDAP. So we've made it available on our private ERDDAP. And then our SBD data, which has the raw data from satellites collecting drifter data, is great to host on an ERDDAP because then you can automate SBD drifter data pools, and incorporate that into the data processing aspect of our QC updates. So there are two benefits to having a private ERDDAP. First is that you can push your dataset updates to the private ERDDAP. You can check how the updates look internally before you are ready to release it to the public. And then of course, like with these two data sets, these are just, they're not going to be made available to the public. They just help us with our own data processing. So there's a lot of future work for the Global Drifter Program's ERDDAP, and we're very excited to continue enhancing the ERDDAP server. As I showed you, the dashboard for ERDDAP metrics is now available to our GDP colleagues and program managers, but there are more updated metrics to come. We plan to add more GDP products to our ERDDAP server, our public ERDDAP server, namely the deployment value maps and some other products. And then this is for anyone in the room. If you have any ideas for drifter-related data sets or drifter complementary data sets that would help you in your own data processing, we can communicate and ingest that data set onto our private ERDDAP if it meets the requirements. So for example, the bathymetry data set that I just showed. We're also hoping to create a GitHub page for our GDP ERDDAP that has some sample MATLAB scripts and some sample Jupyter notebooks in the form of Python, just to show you how to manipulate ERDDAP data using machine-to-machine transfers. We also plan to build an interactive drifter observations viewer. An interactive drifter observations viewer that would be very similar to the Coastwatch Ocean Viewer, but this observations viewer would pull data directly from the ERDDAP using the machine-to-machine transfers. So here is a great list of tutorials and resources for those interested in setting up their own ERDDAP. The Global Ocean and Observing System has created some great seminars, and they've uploaded them onto YouTube. And so those are available here in this link. The ERDDAP GitHub page, which hosts the setup.html file, is available from here. Additionally, if you would like to join the ERDDAP Google Forums, you can request to join with this link here. And the GDP has created its own YouTube tutorial instructing people on how to navigate the ERDDAP interface specifically for GDP datasets. And you can see that here. And additionally, we have developed some data access instructions in the form of PDF files accessible from our data page. And finally, but very importantly, Callum Rollo from Voice of the Ocean, who was featured in the seminar series, has kindly provided his own weblog parsing script in the form of a Jupyter notebook. And so I mainly use that script to generate the metrics for our GDP ERDDAP. So that has been very important and pivotal in our process. And you can find that here. Finally, thank you so much to all of our collaborators. Enormous shout out to PHOD's IT specialist, Jay Harris, who built this shared web server for the first time, and he made the release of our ERDDAP server possible within only a number of months. We also work closely with PMEL's research scientist, Kevin O'Brien, and he was great in helping me troubleshoot any initial issues and also setting up the federation of ERDDAPs between the OSMC ERDDAP and the GDP ERDDAP. As well, a big thank you to the administrators of the ERDDAP forums, Bob Simons and Roy Mendelson, who answered all my questions. And of course, again, to Voice of the Ocean, Callum Rollos, for his metric script. And he graciously shared that with the community. Okay. Thank you all for attending. I will take any questions now, and if we don't have time for all the questions, then please feel free to email me and I'll get back to you.